ridges, dunes, craters, and geological layers are all visible in this single, high-resolution image from Mars HiRISE camera. Every image is shown in enhanced color to best bring out the contrasting features. Image credit NASA JPL University of Arizona. 12 years ago, NASA's Mars Reconnaissance Orbiter launched. The descent of Mars Science Laboratory, i.e., the Curiosity rover, was caught by the HiRISE camera, which has also imaged Spirit, Opportunity, the Phoenix lander, and many other human-created probes. Image credit NASA University of Arizona. With its HiRISE camera on board, it's covered the world many times over, catching the descent and landing of the Curiosity rover. Recent simulations indicate that Phobos, shown here, will deorbit and impact Mars. Further extrapolation indicates that Mars may have once had a third, larger moon that already fell back to the red planet. Image credit NASA University of Arizona. It helped show that Phobos above and Deimos below resulted from impacts, not asteroid capture. The smaller Martian moon, Deimos, has features such as craters, composition, and orbital properties that place it in line with Mars, rather than with a captured asteroid. Image credit NASA University of Arizona. Even caught a far-away glimpse of our home. This image composite combines the best Earth image ESP_048368_9041 with the best Moon image ESP_048368_9044 from 4 sets of images acquired on November 20, 2016. Image credit NASA University of Arizona. Meteors sometimes strike Mars, too, scarring its surface. A small crater and surrounding blast zone on Mars, as imaged by the HiRISE instrument on NASA's Mars Reconnaissance Orbiter on November 27, 2016. When the impact is at a steep angle, like this one, it's very easy to discern this feature's origin. Image credit NASA University of Arizona. Down the rims of crater walls, recurring slope lineae are found. Seasonal flows on warm Martian slopes may be caused by the flow of salty water on Mars, active today when the surface is warm. Image credit NASA University of Arizona. Further analysis showed that these are driven by liquid water, not avalanches. Slope features down one side of Newton crater provided early circumstantial evidence for active watery flows on Mars. Image credit NASA University of Arizona. As these change, water condenses and dissolves Martian salts. Kouprat's Chasma Ridge, imaged in late 2013, did not show any evidence of flows down either side towards the valleys below. Image credit NASA University of Arizona. These then flow down the crater, as before above and after below images demonstrate. Kouprat's Chasma Ridge, as imaged in 2014, shows the recurring slope lineae that were not present a few months prior. Image credit NASA University of Arizona. HiRISE reveals the incredible geology of Mars, like steep crater walls. By carving away portions of the surface, impact craters can give us a view into the ancient history of Mars. Image credit NASA University of Arizona. At Mars' south pole, strange shapes are carved by sublimating dry ice. When carbon dioxide turns from solid into gas, such as when Mars goes from winter when CO2 freezes to summer when it sublimates, it can carve out geological features such as these shapes from Mars' south polar region. Image credit NASA University of Arizona. Dunes are found wherever winds blow the sands, including along steep slopes. A steep slope on Mars shows dune-like features, as the wind-driven sands shift with these. Image credit NASA University of Arizona. Impact craters are found everywhere, even in flat, plains-like areas. Along the large flat region of Mars known as Arcadia Planitia, numerous young craters dot the surface, such as the one imaged here. Image credit NASA University of Arizona. HiRISE also images candidate sites for future landers. A potential landing site for the future ExoMars 2020 mission, which could finally answer the question of whether there's life beneath the Martian surface. Image credit NASA University of Arizona. Potential new discoveries include possible new impact craters. The dark feature shown here towards right center is the possible evidence of a small, recent impact of a meteor onto the Martian surface. Further investigation will be necessary to determine if this idea, supported by HiRISE's circumstantial evidence, is correct. Image credit NASA University of Arizona. Martian bedrock where the sands have been blown away. While much of Mars is covered in sand, regions where those sandy, sparse layers have been blown away reveal a rugged, eroded terrain. Image credit Nasaj University of Arizona. Revealed geological layers down steep crater walls. This very fresh crater with steep slopes allows us to probe the interesting geology of Mars. Image credit Nasaj University of Arizona. New sites with flowing water. Recurring slope lineae, like those shown flowing down from the hilltops here, involve briny water carving new paths down a crater wall or other steep slope. Image credit Nasaj University of Arizona. And newly formed features along gullies. HiRISE monitors geological features like gullies to look for changes over time, as well as to monitor differences on either side of this feature. Image credit Nasaj University of Arizona. With over 50,000 images, HiRISE's catalog is free to view anytime.